Hello students, in this video we'll see an example of how to analyze the critical points of an autonomous ODE. Let's consider the ODE dx dt is x cubed minus 9x squared plus 23x minus 15. There are no t's on the right-hand side of the equation, so no t's implies that the equation is autonomous. To analyze this equation, we'll find the critical points, or the equilibrium points. The critical points occur when the right-hand side is equal to 0. X cubed minus 9x squared plus 23x minus 15 equals 0. We know that the rational roots, the possible rational roots, are plus or minus 1, 3, 5, and 15 by the rational root theorem. And so let's just check some of the easier ones. If we plug in 1, we would have 1 cubed minus 9 plus 23 minus 15. Is that equal to 0? Well, we can check. We will have a 24. 1 and 23 is 24, and negative 9, 15 is also 24. So in fact, x equals 1 is a solution. We can now do synthetic division to find out what the remainder polynomial is. We'll put a 1 in the box, as 1 is our root, and I'll store the coefficients of the polynomial on top. We'll bring the first number down. 1 times 1 is 1. Negative 9 plus 1 is negative 8. 1 and negative 8 is negative 8. Then I'll have a 15. Then I'll have a 1 and 15 is 15. And if we get a 0 here, that tells us we have a root. These coefficients are the remainder polynomial. So our polynomial, x cubed minus 9x squared plus 23x minus 15, is x minus 1 times x squared minus 8x plus 15. And we can factor this. This is x minus 1, and this will be x minus 3, x minus 5. So we have 3 equilibrium solutions. X equals 1, x equals 3, and x equals 5 are our equilibrium solutions. Now we can plot the phase plane. Here's my t-axis, here's my x-axis, here's the solution x equals 1, here's the solution x equals 3, here's the solution x equals 5, and I need to determine the sign of the derivative in each of these cases. Well, our differential equation can be written as x minus 1, x minus 3, and x minus 5. So if I plug in a number less than 1, this will be negative, this will be negative, and this will be negative. So I'll have 3 negatives over here. Negative, negative, negative. 3 negatives are negative, so that means my solutions will be decreasing in this region. If I plug in a number between 1 and 3, like 2, I'll have a positive, negative, negative, which tells me my solutions are increasing in this region. If I plug in a number between 3 and 5, I will have positive, positive, negative, which gives me negative, telling me my solutions will decrease. And finally, I'll have positive, positive, positive if I plug in a number larger than 5. So the solutions will want to increase over here. And now we see from this configuration that 5 is unstable, 3 is stable, and 1 is unstable. Thank you very much.